Okay, predicting from data. Number one, light bulb manufacturer finds that 4 out of every 125 light bulbs that they produce are defective. If the plant makes 2,500 light bulbs in 1 hour, how many defective light bulbs should they expect to produce in 1 hour? So the easiest way to do this is to set up a proportion, which is going to be 4 out of 125 equals X over 2,500. Now, a couple ways to do this. You could cross multiply, which is going to give you 10,000 equals 125x, and then divide by 125. Or you could figure out what can I multiply 125 by to get 2,500. The answer there would be 20. So then you just do 4 times 20 on the top, and you get C, 80. So that one is not too bad, right? Wow. Number two, Madison asked 40 students to select their favorite course and then recorded the results in the bar graph below. Madison will ask another 180 students to select their favorite class. Based on the bar graph, about how many more students should select civics rather than biology as their favorite class. So, out of 40, I'd say about 14 selected civics and 10 selected biology. So 4 more civics than biology. So it's 4 more civics than biology, right? And that was out of 40. So 4 out of 40, and that is 0.1. And so then we can take that 0.1 and multiply it by 180 to get 18. Number three, a wireless phone company determined that 12 out of every 350, ratio again, set up into a proportion. You can more or less guess it. Okay, so now I'm just going to get out a calculator. Do 2,500 times 12 and then divide by 350. Gives you 85.7, and so they should expect 86 phones to be returned. All right. Number four. Shipping company charges the following fees to ship a package based upon the weight of the package, which equation could be used to determine the price of a package Y given the weight of the package X in pounds. Okay, so number four, just check and see what it goes up by each time. So your weight goes up by 1 each time, and your cost goes up by $1.50. So basically, all you need to know is whatever one goes up by $1.50 each time. Number five, Jordan asked 20 students to select their favorite sport and then recorded the results in the pie chart below. If Jordan's results represent the entire student population, which of the following statements is true? So if you ask 20 students, then 20% of 20 is 0.2 times 20, which would be 4. So 4 would have said hockey. Basketball would be 0.35 times 20. which would be 7. And then football would be the rest of them, which would be 9. So if you asked another 150 students, that's really not all that important there. But if you ask another 150 students, then it says 115 would select basketball. We could just do 0.35 times 150. That is 52.5, which is not 115. So A is out. If it's 120 students, 66 would select football. So you would do 0.45 times 120. That gives you 54. So that one's out. So basically, you're just taking the number of students and multiplying by whatever percentage it would be. So 130 students times 0.2. That would give you 26. So let's see. Number 6, an apple orchard charges the following fees to pick your own apples based upon the weight of the apples. So it goes up by, just do 725 minus 450. That gives you 270 or 275. Check to make sure that's true for 10 minus 725. If it is, then you automatically know that it's D, because it's going up by 275 each time. Okay, a steel plant in Pittsburgh recorded its demand for standard and stainless steel during a 6-week period. Results are shown in the plot below. Determine when the difference between the demand of standard steel and stainless steel changes the most from one month to the next. So basically, you're looking for the largest change. Shouldn't be 1 week to the next. It should be 1 week to the next. So if it's going from 1 week to the next, if you're looking at the standard steel, just do like 60 minus 25 maybe, because that's the largest drop off between weeks 2 and 3. Then between weeks 3 and 4 is what it would be for the stainless steel. So that one's really easy. You could just say, using the prediction in the data or using the chart, the biggest drop off is between weeks 3 and 4, and that would be no big deal. They would completely get that. Put the numbers in there though. So like make an approximation for this to be like 65 or 70, and then this to be 25. That way they know that you know exactly what you're talking about. If the increase in demand for both stainless steel and standard steel continue at the same rate, how much stainless steel will the plant produce in week 9? Show and explain your work. So from week 5 to week 6, for stainless steel, it goes from 25 to 50, or close to 50. So if it goes from 25 to 50, then that would be an increase of 25. So then weeks 6 to 7, 7 to 8, and 8 to 9, you would do 25 times 3 more. 25 times 3 gives you 75, and you add that to the 50 that's already there, and it would be 125. For the standard steel, it's going up by about 12 and a half. And so here it would be at like 62.5, and then you just do 12 and a half times 3, which would be 37.5. So do 37.5 plus 62.5. And you get 100. Alright, that's it for that one. Only one more section left. Then you guys are done with this class for the year.